Okay, guys, good evening or good afternoon or good morning, whatever that we have. Now, I want to start from, I need to correct something. There was a question we did on Monday, and I want to correct something there because it affects a whole lot of our theory answers. That paper was Mpumalanga, so we need to quickly correct that error. We need to correct that error. Resources. And from there we just move. We can run through that paper. And if there's any other question, I'm still open to receive. We're still open to receive. Okay, and today let's deal with some multiple choice as well. I think we did some multiple choice that, oh, I see a graph there, beautiful. I want that graph. All right, we did this, we did that. Okay, quickly, there's just a correction that I need to make on this one, just to call our attention to it. There was something that we said which we need to correct. Okay, now if you look at this diagram, now you remember, and the examiner said, you see, I think what they set this paper in such a way that you would answer that before coming to 10.2.2. Now we got 10.2.2 correct. We were supposed to go back to use it to fix, but we just carried on. So this thing, if you remember, it shows this is AC power supply. And that changes the whole question. If there's a power supply, it changes this from being a generator. It makes it now what? A motor, because we are converting electrical energy to mechanical energy. I'm following your lead now. Okay, so this is a motor because it's a power source. Name the principle. A motor would work on the principle called the motor effect. Take note of that. Generators work on the principle called electromagnetic what? Induction. I prefer Faraday's law because I know this examiner sometimes smoke some things. They say if you don't write Faraday's law, -1. So, okay. Name and function of the component D. D is an AC what? And it's a power supply. So it supplies what? AC. It supplies alternating current. All right, and the polarity now. Since it's a motor, we now use what? A left-hand rule. Okay, I tried to do a little video of the right hand and the left hand. I don't know if that worked. So if it's a left hand, but did they tell us where current is? Oh yeah, current is, okay, I was going to say something is wrong. Current is flowing from P to what? Q, which is that way as well. So if you put your left hand, yeah, so X should be north and this should be south. I'll do a video where I'm facing the board of just this question, just to show you the right hand and the left hand rule, but I'll do it early in the morning tomorrow. Not today, I don't have time to do it today. But please watch that video that I did today. It would really help on the right hand and the left hand rule. Okay, that was all about this. Other questions were fine. So that AC power supply was just the problem. Okay, let's move up this paper. All of this were good. Fine, fine, fine. Everything was flowing here. All right. You have your formula page, guys. Quickly. 10 marks here. 10 minutes here. Doppler effect. Quickly. 10 minutes. Let's see what you can remember. And I like this one because it's waves. they gave us waves. Quickly, guys, so we finish this paper, then we can take any other question, but I want to do graphs. I want to do questions on graphs. Okay, guys, I think we are done here. We got to run quickly. Now, the siren of an ambulance emits sound waves of frequency 1836 hertz while the ambulance is moving at constant speed. Don't forget, moving at constant what? Speed. A learner standing next to the road with a detector observes. So our listener is stationary. The graph of air pressure versus time below was obtained from the detected sound waves by the detector. Take the speed of sound. Now, please get back to your definitions. I know tonight is when you guys, your memory is open for such things. A night before is when you guys are very active in swatting up these definitions. Please, let's know it. It is the observed frequency when there is relative motion between the listener and the source. There must be a relative what? Motion between them. All right. Now, if you look at this graph, let's look at this. Do you notice that we have one full cycle of a graph? Yes. And what is period? Okay, before I even go to number 2, what is period? Period is the time taken for a complete wave or vibration to pass through a point. To pass through a point. So if I were to ask you what is the period of this graph, what would you say? Do you notice that this is actually halfway? So if we were to complete the other half, what do you think the time would be? 6,25. That is very, very important. Once you see a graph like this, you must be able, because you just multiply that by 2. Why? I see the next question. They said what? Frequency. So how do you calculate frequency? Frequency is 1 over T. Grade 10. And T is the period. So F equals to 1 over what? 6,25. Please don't forget. What's your frequency going to be? 1,000 hertz. 1,600 hertz. Are we on the same page there? Please talk to me. That's very, very important. Once you see a graph like that, please expect that. Am I audible? Can you guys hear? Okay, yeah, you can hear me. Let me know if we are okay with that. Please, very, very important. Once I see a graph, I know the examiner is going to ask you that. And that second question is, the next one is also prevalent. They are going to ask you for that. What are we looking for? Wavelength. What is wavelength? Lambda. What's the formula? V equals to what? Now, the common mistake that learners make is this V. They usually take the speed of the car. No. If everything here is talking about waves. So this V is sound waves, which is what? 340, which is 1,600 what? And what is my wavelength going to be?
You say sound waves emitted by the siren. So isn't it 1,800?
Wait. Wavelength of the sound emitted by the siren. This one is detected. So what's the frequency of the sound? 1836 lambda. What's your answer? 0.19 meters. So both the detected sound and the released sound are traveling at 340 because that is constant. Are we okay? Are we okay? Then we go to 2.3. Please talk to me as quickly as possible. I want to see if we can cover a whole lot tonight. Okay. 2.3. Speed at which the ambulance is moving. Now, here, the examiner didn't tell us either towards or away, right? We need to figure it out. Do you think we can figure it out?
Yes.
How? How?
The learner is aiming at the towards or away.
Didn't?
It's lower. What he observes is lower than the actual frequency.
So what's the frequency of the listener? 1836.
No, that's of the
Of the source, rather. And the frequency of the listener was the one we got. So if the frequency of the listener is lower, it means the car is moving away. Okay. And if it is away, what do we know?
minus on top plus.
Minus on top. Please don't forget these ones. If it's towards, plus minus. And that's just helps us deal with that. Okay. Please don't make this mistake. Don't come out of the exam and say, oh, I made a stupid mistake. Yeah, this is listener. And this one is what? Source. Copy the original formula. Now let's change the formula. Which one is stationary again? The listener, right? I like to just take it out. And I said minus and plus there. What are we going to have? Do we know FL?
Yes, 1,600.
1,600. 340 over what? 340 plus VS. But can I tell you something? Tomorrow, it's simultaneous. I can bet on that. Tomorrow is a simultaneous one. Okay, but anyway, do the math here. What would the math be?
VS is equal to 50,115.
Okay, let's wait. How did you get 50? What did you do?
1,600.
Or used your white calculator?
1,600 divided by 1836. Switch the 2 minus.
Good. That's the simplest thing. If I'm looking for this, I just switch this. 340 plus VS equals to 340 over what? 1,600. And this is 1836. Whatever answer I get, I would subtract 340 from it. You said answer is? 50. Wrong answer. Meters per second. Is that the answer you guys got? Let me know. Or is there anybody who's lost? Anybody with a question? The last one, please Google it. State one use of one application of Doppler effect in medical industry. Blood flow meter, ultrasound, heartbeat of the fetus. Okay, blood flow meter we mentioned, right? This is grade 10. I don't know if I know you don't remember doing it in grade 10, Shamir, but this is grade 10. Uses of ultrasound. Okay. Oh, sorry. What is the frequency of the sound waves detected by the driver of the ambulance? Choose from greater than, equal to, or less than. It is equal to. It is what? Equal to. What's the reason for it being equal? The source and the listener are moving at the same speed. So there's no relative what? Motion. Are we okay? The source and the listener. That's why when you are driving or you're in the car, the music sounds the same. But for somebody else, or the siren sounds the same if you are driving. But for you outside or someone outside, there's that increase and decrease, pitch and whatnot. But for the driver, they hear the same thing from beginning till the end. Let's do a quick summary on the graphs of this thing. Are we okay, please, everybody? Graphs. I'm going to draw three graphs. First graph, constant speed. If we are moving at constant speed, what are we going to expect? All right, if that is the frequency of the source, since it's at constant speed, I'll have that and I'll have that. And you should understand what that means quickly. Let me write A here. I want to see if you guys will be able to tell me something here. Which one represents towards movement? The listener is moving towards the source. Which one, A or B, represents towards, and which one represents away? Yes, Shamil, come back to earth.
I still put it all on there. This is moving towards. Only nothing.
A for?
Apple.
A for air friction. Let's have a. When the listener is moving towards the source, the frequency observed will be higher. So the one on top is what? Towards. And the one below is what? Away. Okay, I got good answers from those of us at home. But the line is only straight like this if we are moving at constant what? Speed. Now let's change the whole scenario quickly. We only have 5-10 minutes on this one. And let's say, okay, source is stationary. All right, constant speed of VL here. What will my graph look like in terms of the frequency? If VL is moving at increasing acceleration, the speed is no longer the same. This guy is driving faster. What's going to happen to the frequency of the listener? All right. Listen, I don't want you to cram this thing. Let me show you how to figure it out. Go back to the formula very quickly. What's your formula? FL equals to what? V plus or minus what? VL. Oh, increasing acceleration, let's say towards.
Oh, yeah, now you can.
Increasing acceleration towards. Direction is important. Okay. V plus or minus. Don't cram it. Just quickly work this out. Takes a few seconds. If it's towards, what do we know? This one should be what? Plus. While this one should be what? Minus. Okay. The source is what? Stationary. Check here. This whole thing is V. Now look at where VL is. Do you notice if this number increases, the whole numerator will increase? And if your numerator increases, FL will increase. So my graph would look like this. Because that is FS. Now all of this would be what? FL. Because as the speed increases, you see, as this speed increases here, this whole numerator will increase. FL will also be what? Increasing. I don't know if that makes sense. Let me see if there's anyone who's confused, because I want to give you one now. Yes?
So, can you please do what you just did for the first one as well?
Sorry?
Can you please do what you just did for the first one as well?
For the first one? That one, there's no need. The speed is, you see, the speed is what is changing the frequency. If the speed is constant, it means it's not changing. So check. If you get what I'm saying, right? If the speed is constant, the numerator stays the same. So FL will also stay what? The same. All right. So once the speed is constant. Now, I want you to do me one. Do the one for, yes, increasing acceleration away. Draw the graph. Increasing acceleration away. That is, VL is moving away. VL is increasing acceleration but moving what? Away. Use the formula, please. Don't cram it. You have 30 seconds. These are the things these examiners are looking for. I have a paper that I want you to go and try. I'm looking at it now. So guys, we're finishing early. You have time to do a full paper. Northern Cape. I'm looking at it this year. It's got some trials. Yeah. It's got some nice things. I'm looking at it. So I'll send both the question paper and the memo. Please do it diligently. Give yourself 3 hours. Walk through. It's really looking, yeah. I think I'm liking what I'm seeing. Okay, are we done? Now, first thing is to look at the formula, right? What's the formula saying? FL, since it's moving away, it's minus on top. Is that fine with us? Okay. What do you notice? Oh, just V, right? Okay. If this number, VL, we're saying increasing, do you notice that the numerator will be getting smaller? Because it's a minus. The other one was a plus. So this whole thing, as this thing increases, this whole thing becomes what? Smaller. What do I mean? Check. 340 minus 10. 330. Then this guy increases the speed to 40. 300. Number is becoming smaller. Imagine this guy now drives like me and drives at 300. You need to see me when I'm late. 40. So as the speed increases, the difference does what? Decreases. So what happens? If this whole numerator is becoming what? Smaller. Where's my stuff here? If this whole thing becomes smaller, what happens to this guy? Because it's a numerator, also becomes what? Smaller. So you can adapt this to any of the questions. Are we good, everybody? Everybody okay? I need a redshift question. I need a red shift and a blue shift question. Yeah, we can make one, you know. But I think I saw one on the multiple choice. Beautiful. I can use this one. I can create a few things here. There we go, guys. Let's answer that question quickly. Then I'm going to change something here. Oof. I'm walking on water here. Yes, are we done? What's wrong? Doppler effect is not your friend. But the theory is actually a lot easier. Okay, can I get answers? What are the answers? I'm seeing a B, I'm seeing a, oh, it's a BB. Okay, let's see. What is the question saying? Astronomers obtain the following spectral lines of an element. Okay, so In the lab, we look at that, and in the distant star, we look at that. What do you see here? You would notice that when we observe it in the distant star, the red has shifted towards, the lines have shifted towards this. This is actually this, moving towards the red. So we call it a red shift. Right? And if it's a red shift, what are we talking about? Moving away. Red is moving away. Red is danger. What do you do from danger? You run away. Can I change the question quickly? The universe is shrinking, then we are all dead. I want to change the question. The spectrum of element 1 from distant star and the spectrum of element 2 from a distant star. Which one of these is moving at a greater speed? Okay, my question would not be fair. My question would not be fair if I don't. Let me do it like this. I want it to be fair. So I have two stars A and B. Which one is moving at a greater speed? I don't have a B here. I have 1 and 2. Which one is moving? It is star number 2. Now the degree of the redshift tells us it's gone too far. And it has gone too far too fast. So it is more, if they ask you for a reason, it is more redshifted than star 1. It means, you know what redshift simply means? A longer wavelength. Look at a longer wavelength. So that's what really tells us that it's moving faster and it's further away. Okay, I think the rest is the rest is okay. Okay, quickly let's move. Oh, I like these ones. You know me, I like these ones. Please give me 1.5. Give me 1.5. Huh?
What kind of light are you using to go that far?
What kind of light? What do you mean?
But how does it go that far? How does it reach the star? The star is very far away.
For those of you struggling, let me give you a hint. Number one,
Never mind,
calculate the old kinetic energy. Then calculate the new kinetic energy. Then divide.
No, I was getting it, but I wasn't dividing it right, so it wasn't making sense.
2 squared is what? 4. 8 squared is 64. So it's 4 ratio 64.
4 ratio 32. We have to add.
No. They said it's moved from 2 to 8. I already removed the half
Oh, okay, yeah, I see.
because the half. So it's 4 squared. 2 squared. And what? 64. So 4 to 64 is 1 to 16. Okay, so here quickly, if I were to calculate the old kinetic energy, half what? mv squared. What would that be? Half, what is my 2 squared? What would this be? 4 divided by 2. 2m. What about this one? Maybe I'm wrong.
No, you're right, you are.
New kinetic energy. It is half also mv squared, but it's half m8 squared. What would that give us? 64 divided by 2? 32. Now what's the ratio? 1 to 16. We're done. 1 is to 16. And that's how we walk around such questions. Okay, I hope that makes sense, everybody. We just old and new, and then we compare. All right, let's see. I think let's just answer all of this multiple choice quickly, then we go to the word problems of these topics. Quickly, everybody. Yep. Which one of the following physical quantities represents the rate of, 30 seconds. Rate of change of moment. What I'll tell you is to write that formula. Rate of change of momentum. Rate means divided by time. Write the formula, Shamil. Change that thing into formula. Rate of change of momentum. Once you write that, you will be able to see what you're doing. Can somebody give me an answer now? You sure? Answer. Rate of change. Rate is divided by what? Time. Change in momentum. Newton's second law in terms of momentum. And what is this equal to? Can we define Newton's second law in terms of momentum? Can you change this thing into words for me? Change what you are seeing. Just change it into words. Let's go. Now, the net force is equal to the rate of change of momentum. That's Newton's second law in terms of momentum. We're done. So it's the formula. The net force is equal to the rate of change of momentum. All right. So please, when you see questions like this, change it into a formula, and then we answer. Oh, beautiful. Graphs are my thing. Come, let's go here. I love this graphs questions. Then we now go to the mechanics part of this paper and answer. Let's go. Two minutes. What I'll tell you while you are reading. Read and draw your own. No, don't gamble here. Today, one learner was gambling with multiple choice. She had an eraser, like the shape of a box. I promise you. And she wrote A, B, C, D. I saw her shaking and throwing it on the table. And I looked at her. And she said, no, answer is B. And I'm like, what? Like, this is next level.
it's going up and then down. Yeah, so they're saying up is positive and then down is also positive.
What's the answer?
That's what they say.
Yeah, for A.
Both can't.
Answers,
Both
please.
down can't be.
Answers? Alright, this is my fresh answers. I'm seeing a lot of beef. A stone is thrown vertically upward and returns to the thrower's hand after a while. Which one of the following graph? Please, they said velocity. Please take note. I'm going to show you two answers here. The answer is 1. But if I change one word,
Okay.
then the answer would be wrong.
Okay, do that, but give us a chance to see.
Okay, alright. Which one of the following best represents? So guys, please understand, they said it is thrown vertically what? Upwards. What should come to your mind is it goes upwards and then comes back to the thrower's hand. Velocity here is what? 0. So as it is going upwards, what's happening? It's decreasing.
Okay. Oh, yes,
Velocity is decreasing. Alright, and then as it's coming here, it is what? Increasing. But in the opposite what? Direction. So the correct answer would be what? B. Because you can see here, it starts from something high and then decreases, gets to what? 0. And then changes direction. Can I change this? If I put speed, what is going to be the correct answer? Will it still be B? Let me help you, it's not B. It's not B.
What's speed and velocity?
No, speed is a scalar.
Oh, speed is a scalar.
Velocity is a vector quantity. Grade 10. Grade 10. What's our answer here if I put speed?
All chips in one thing.
Alright, the correct answer is A. Because once I put speed, it's all positive now. So you would notice the first part of the graphs are the same. But because I said speed, so you see that, same thing is happening here, which is 0. But because I said speed, it has to be, there's no negative there. So the velocity starts what? Increasing. Can you see that again? So please take note. If I'm an examiner, I'll do something like that. I'm sorry. You must just have a bit of an evil heart when you're an examiner. Just small. Because if we change it to speed, a lot of people would say B, 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 B. And they'll just get it wrong. And simply because we don't read in between the lines, we quickly assume what the examiner is saying. All right, so please take note of that. Read, highlight, or whatever. Ooh, why is this one so long? I don't like these long ones. Okay, but I'm sure. Please, I did one question like this today, and I posted it on TikTok. It had to do with gravitational acceleration. Please go check that thing. It's quite intense.
For acceleration, small g, you only need mass to the planet. If you give a mass to someone, then you can't.
Okay, here we go. Let's put a time frame because of the reading. 2 minutes, 30 seconds. Please read, analyze, then choose your answer. Okay, I think we should be done. Let's read. Two isolated bodies A and B having masses m and 2m respectively are placed r distance apart. Consider the following statements regarding the gravitational force exerted by the bodies on each other. This is universal law of gravitation. The force exerted by B on A is half that exerted by A on B. That's completely wrong. What law cancels that? Third law.
Yeah, Newton's third.
Newton's third law. If body A exerts a force on B, irrespective of the masses, and because I've said irrespective of the masses, I've cancelled out the second one. That the forces exerted is independent. Wait, the forces exerted on the bodies is what? Independent. That's wrong, because the forces is dependent on the mass, because it says the product of the mass is directly proportional to the force. So if the masses are big, the force is big. Number 3, the force exerted by A on A by B is equal but opposite. That's fine. That's correct, right? That's Newton's what? Third law. What about number 4? The forces will always be, if you state the law, all objects in the universe attract each other. That's where the answer is. So 3 and 4. Correct answer is C. Please, guys, tomorrow, reading time, see how many multiple choice you can get. Don't do the ones with the calculation. Obviously, you need a calculator, they won't allow you. But while sitting down, you don't need a calculator to answer this. So don't read. No, leave. Reading time, question 1. Question 2. And I think most of them, look, try with this paper that I'm sending to you. Give yourself reading time and focus on multiple choice. Let's see how far. I already sent the paper and I sent the memo. Let's give ourselves some test. If you send me a challenge after this class, I will only respond 4 a.m. tomorrow. So in case you want to send a problem, be ready to look at the solution early in the morning. Fair enough. You see, like this one, you are waiting for a car for them to tell you to start writing before you. No, man, come on. Which one of the following forces always acts perpendicular to the surface? It's normal to have a question like this. I've already given you the answer. Okay. All right. Acts perpendicular to the surface on which a body. So please, multiple choice, get as many. Don't struggle. If there's one you are not sure, leave it. When you get to the topic of that question, keep at the back of your mind, I haven't answered that. While thinking through the structured questions, you might stumble on that multiple choice. You go back and fix it immediately. All right, guys, let's go do some serious business now. We've been playing. Oh, beautiful. But you know where I'm going. I saw a graph. Oh, let's start from here. 12 marks. Work, energy, and power. Can I give you some time to just try, please? Free body diagrams and everything must be in. Then we just work our way up. Please don't skip any of these laws. Yeah, we're skipping any of the laws. 13 minutes because the first one. Please start from the. I wish I could cover this thing. Please read. Please read. Take a moment to read. I know these boys, they want to start answering 5.1. Are you guys winning? Time is almost up.
So is the answer 26,46? Remember?
All right, guys, let's quickly walk through this. Let's walk through this. A force of 80 Newton pulls a 20 kilogram object at an unknown angle for 4 meters on a horizontal rough surface from rest at point P to point Q while experiencing a constant frictional force of 45 newtons. When the object reaches point Q, the force is removed and the object continues to move up a curved frictionless surface to stop at point R, all right, which is 40 centimeters. First problem. What is that? Divide by 100. Okay, first problem there. All right. State the principle of conservation of mechanical energy. Please, that's 2 marks. In an isolated system, the total mechanical energy is conserved. Is mechanical energy conserved or not while the object is moving from point P to Q? Answer is no.
Yeah.
Why? There's friction. The system is no longer isolated because friction is an external what? Force. You see those questions? We get them quickly. 5.3.1. Calculate the magnitude of the angle theta shown in the diagram below using energy principles what? Only. Now, I remember your argument on energy principles where you were marked wrong. You told me. Now, when they say energy principles, you are allowed to use work done by non-conservative. You can use work net, you can use anything. But when they say work energy theorem, just stick to work energy theorem. So we don't look for trouble. Okay. Now, using energy principles, guys, for me, the examiner did not say draw a free body diagram, but life becomes a lot easier when you draw. So let's look at the free body diagram there. What are we going to have? Applied force, which is that way, right? What do we have again? Normal. What do we have? Fg. If the object is moving to the left, friction should act where? And by now, every one of you should know, you are now old enough in physics, that friction and applied can act in the same direction. It has nothing to do with applied. Friction has everything to do with the direction of motion. Okay. So what do we have? We have 80 newtons. We have what? Normal. We have what? Fg. And we have that. Okay. Let's see. Use energy principles. When they say energy principles, I could work with my work done by non-conservative force. All right. I'm going to quickly go to a fresh page. Let's analyze very slowly. We have that. We have that. We have this. And we have this. I'm going to use both formulas for us. Friction, Fg, this is 80 newtons, and that's normal. Now, guys, I cannot work with, I don't like working with inclined forces. So what do? We resolve, right? Okay, so let's resolve together, everybody. We have normal, we have gravity, we have friction. Now I'm going to resolve the other one. What are we going to have? Vertical and what? Horizontal. So I have my normal, I have my Fk. Okay, in order to resolve this, that is theta. So this is Fy, and this is what? Fx. Fy is opposite, so we use what? Sine. Quickly, don't waste time. So Fy would what? 80 sine what? I don't like this theta thing. Okay, let's leave it like this. But I don't like it. And what is this? 80 cos theta. Now let's use our work done by non-conservative, which is actually the same even if I use work net. If I say work net is equal to change in kinetic what? Will this help?
Yeah.
Will this help? Will this help? What do we know? What are we looking for again? Angle theta. It won't help. Do you know why? Because we don't have the final velocity. We are working between P and what? Q. So I don't think that would help.
Sir,
Yes. Or were we given anything? Yes.
can't you get, between R and Q,
Between R and Q, yes?
you can get initial velocity from that. If you use the W net, if you use the W NC, you can get the initial velocity.
Alright, let's see. So we do not have the velocity at this point, right?
Yes.
Okay, let's see something here. But we do have the velocity at this point as 0. And there is no applied force. That's an isolated system. So we can work backwards. Okay? We can work backwards. So that's going to be our only, because I see here, we have to say what? 1 over 2m Vf squared minus what? This we know as 0, but this we don't know. So if we go back to that curved surface, this is Q, and this is what? R. We note the height here as what? 0.4 meters. And because this is frictionless, it is what? Isolated. We have the final velocity at this point as 0, but we do not have the initial what? Velocity. Can we then use work done by non-conservative here? Work done by non-conservative is what? Change in kinetic plus change in what? Potential. And in an isolated system, the work done by non-conservative is what? 0. So 0 equals to what? Half m Vf squared minus Vi squared plus mg h final minus h what? Initial. Do we know the mass? What's the mass? 20. Okay. Do we know the final velocity? Yeah, we know the final velocity as 0, right? But we don't know the initial. This initial is what we need on that side now, right? Okay, plus 20. Now be careful of this. This is the initial height, and this is the final height. So 0.4 minus what? 0. Let's do the maths. What do we have? 10, negative 10 Vi squared. What would this give you? 20, 70? All right. So can I then move the 10, negative 10 over? 10 Vi squared equals to what? 78, 4. What is Vi squared? 7, okay, don't give me V. Don't give me V. I just need the Vi squared. All right. Now, if I go back to where we were stuck earlier, we can now find our way through. Now, if I use work net, are you aware that the only force here, there are two forces, right?
Yeah,
And both of them, even if I use non-conservative, it will still be the same. Because we have applied and friction. So this is work done by force applied plus work done by what? Friction. Please be very careful. I need a different page to do this. Are we on the same page so far? Now, what is my work done by applied force? Please be very careful of this theta thing. It's annoying. You need to know which one you're dealing with. So, we said work done by force applied plus work done by what? Friction is half m Vf squared minus what? Vi squared. This is what? Force applied delta x cos theta. This is not the theta we are looking for. Alright, plus friction delta x. This is not the theta we are looking for again. You know what? To make life very easy, I want to do something. I want to do it in a different way. I'm not going to bring force applied. Now, if I look at my diagram, my free body diagram is going to tell me theta. For this one, theta here is always what? 180 degrees. Always. And this one is opposite. Theta will be what? 0. Because the object is moving in that direction. So please take note. I really love alpha here. Okay. But I see how to not get you confused. Don't let us substitute that. Because we will have cos theta. So let's leave it. What is my displacement? 4. What is this? Cos 0. Do we have frictional force? 45. What is the displacement? Please, friction is always what? 180 there. What is the mass? 20. What is the final velocity? 7,84. Don't forget, don't go and square it again. Okay, what do we have? 4F. Do you want to give me answer? This? Okay, let's do it step by step. What would this give us? 40 is 45 times 4. 0, 2, 16, 180. And it's negative, right? What would this give me? 78,4. Can we then say 4F is what? 180 plus that will give us what? 258,4. By the way, this is Fx. What is that Fx? 80 cos, do you see how I'm trying to separate the two now? 80 cos what? Theta multiplied by 4. Okay, let's work now. What is cos theta? 258,4 over what? And instantly I can just look for the arc cos of that. What is your answer? It must be smaller than 90 though. Was that what you got? Please look at it and let me know where we are lost, where we feel confused. Please let me know. If you are okay, give me a thumbs up. If you are not okay, sir, isn't the final velocity? No, Tando. The final velocity is not 70. Okay, wait, Tando. What are you saying again? Tando, do you want to unmute yourself? Let's clear the issue out. Tando, unmute yourself and let's quickly talk very fast. Let me explain my 78,4. Maybe it would help you. So, what we did was we reversed the whole situation and got, you see here, let me go back to the diagram. So we used this part. Final velocity is 0, initial velocity here. But if I then consider this part, the final velocity, so we actually got, okay, let me do it like this. We got VQ, all right? VQ squared, 7, what? 84. Now, if I consider this part, do you notice what's happening? That velocity that we got, which was final, becomes the initial. Tanda, I don't know if we're on the same page. Are we on the same page? Quick response. Please, if you want to do what I did, don't forget, I didn't find VI. I just left at VI squared. You can find VI and square it again. You know, you like to do a lot of work. I don't. We're good. All right. We're good, Shamil? Good, Letabo? We okay? All right. Eh? You did something wrong. What's the next one? Power delivered by the force F if the time taken for the object to move from point P to Q. Okay, what are we looking for? We're looking for power. Let's make a list of the things that we have. They said power delivered by what? F. If it takes 2,86 to move from what? P to Q. Okay, we are looking for power. Let's make a list quickly. This one shouldn't take us time. We're looking for power. But what do we know? We know time, right? Is it 2,86? Yep. Okay, guys, what formula would you use here? All right, P is equal to W over what? Delta T. And what is W? F delta X cos what? Theta over what? Time. The question is, what force are we using? Keep it as the horizontal component of the force because of that theta. You see that theta? So what is Fx? 8. Huh?
Use FX, we won't use that.
Yeah, because we're dealing with horizontal. I can use F applied. I'll show you.
So,
I'll show you. Yes?
isn't F 80 meters?
Yeah, it's 80.
Sorry?
We wrote 80.
Isn't the value of F 80?
Oh, is it 80? Okay. 80. Cos what? 0. What's the time?
2,86.
What's your answer?
90,42.
90,42 watts.
What?
Now, if I don't want to use, if I want to use F, look at what I would do. When we write this formula, W is F delta X cos theta. What is theta? It's the angle between F and delta X. So we had something like this. The force here is 80. We know this angle as what? 36, comma what? And that is my displacement. So what is my force? 80. What is my displacement? 4. Cos of the angle between both of them. And that's exactly what I have here. Because this one is 1. Cos 0 is 1. So theta is the angle between the force and the displacement. All right. Beautiful. Guys, are we all on the same page? We're doing well so far. If you combine last week's lesson and this week's lesson, our full paper is almost down the slope now. So please, you answer a fresh paper. If you need anything, come back to whatever section we discussed here and work. But yeah. And let's assist each other. Should somebody need help on the group, please don't be shy. Let's assist. Even if your answer is wrong, make an attempt. There we go. 11 marks. Can I give you 10 minutes? 10 should be fine. Okay, did you guys finish? Thumbs up, thumbs down? The guys here are still working. Number 4. Can I add 3 minutes? Let me add 3 minutes. Just 3. Okay, let's mark quickly and let's see what we need to do. A learner of mass 60 kg is standing on a stationary skateboard of mass 5 kg while holding a school bag of mass m. After some time, the learner throws the school bag horizontally at a constant velocity of 13 meters per second to the right. Look quickly. I have not read this, but I know that the learner should move backwards. Why should the learner move backwards? Use physics to explain why the learner should move backward. Newton's third law. So the learner throwing something forward is a force on the bag. Now the bag will exert a force equal in magnitude but in opposite what? That's what pushes the learner backwards. Okay. Immediately after throwing the school bag, the combined learner skateboard system has a change in momentum. Good. 6,5. You see, to the left. Assume that the system is isolated. Explain what is meant by the term isolated. What did you say? Huh?
There are no external.
A system with no external what? Forces. Number 2, calculate the velocity of the learner skate after throwing. Okay, let's see. And the learner, they're talking about changing what? Momentum. What do we know? What are we looking for again? Velocity of the... Okay, what do we know? We know that the change in momentum is negative 6,5 if I choose right as positive. We're looking for the velocity.
And we have
Is the right answer.
Do we have...
initial velocity.
Okay, but it's both of... No, wait, hold on. Learner skateboard, and a learner of mass 60 standing on a skateboard of mass what? 5. So this is of learner and what? Skateboard, and changing what? Velocity, negative 6,5. Do we know the mass of the learner? 60 plus 5 will give us what? 65 V. So what is V? Negative 0,1. So what is the velocity? 0,1 to the what? To the left. That's very important. What about the... Yes?
It's 10.
6...
Or
Huh?
No.
Are you doing 65 over 6,5? Because it's 6,5 divided by 65. And that would be...
that's what I did wrong.
Yeah, okay. 0,1. Okay, good. What about the mass of the school bag? Can we use our momentum to get this one? Because that's the only point where the mass comes in, right? So do we know? M1 plus M2, they were together, right? Plus M3 VI will be what? M1 plus M2 VF1 plus M3 VF. I don't know if that makes sense. I'm just playing around. I'm tired, so I'm, just enjoying myself. Okay. M1, M2, M3. M1, let's call it the mass of the boy, which is what? 60. Is he a boy or a girl? A learner. Okay. What is the mass of the skateboard? 5. We're looking for M, right? But stationary, 0. Now we have this one is 60 plus 5. What is the final velocity? Sorry, wrong. Negative 0,1. Okay. Plus, wait, hold on. Oh, the bag moves what? 13 meters. I wanted to say something is missing. So what do we have? 0 here will be equal to what? Negative 6,5 plus what? 13m. So what do we have? 13m equals to what? So what is m? 0,
5 kilograms.
all right. Oh, I love this one. Somebody asked me this question today. Please, very important how you answer the next one. Motor cars are equipped with safety measures which play an important role in saving lives of passengers. Name any of the safety measures modern cars are equipped with.
I'm going to go with people this question.
Okay.
The answer they're looking for is a seatbelt. And I can say automatic braking system. And that is a modern car feature.
All right. Can we stick to old cars? All right. We have examples. We have what? Seat belt. We have crumble zones. So, yeah. So those are common examples. So you would find out that a car that has a bonnet, you are safer than a car with a small bonnet, like a VW Beetle. You are not very safe there if you have an accident because your bus, like your combis. You see your combis. Mini Cooper is still safe because it has a. Am I right? Mini Cooper still has a front. So you see all these engine parts. It's called crumble zones.
whole of his car just went
Inside.
folded in half.
Yeah. So, but how are these important? Please, the next question is what's important. Explain using a physics principle how the safety. Now, this is what happens. This is how you answer. You answer by saying, you see these crumble zones, they only do one thing, they increase time of contact. So, all this will do what? Increase what? Time of contact. But what happens with the time of contact? You would say for the same change in this statement is very important. It's 1 mark there. For the same change in momentum, F net is inversely proportional to time. So the longer the time of contact, the smaller the force of impact. Please, that's how we answer. If you want to write down, you can write. I want to do a quick summary on elastic and inelastic collision. What is an elastic collision? Total something.
Total energy is conserved.
Okay, please take note. 2 things are conserved. A collision where what? Both momentum and what? Kinetic energy are conserved. And that would lead you to a simultaneous equation. Once you see the word elastic, if the question has elastic, please, you do the momentum, then you'll do the kinetic energy, and then equation 1 and equation. That's very, very important. Okay, what else do I want to say here? So we're saying M1 VI1 plus what? M2 VI2 should be equal to what? M1 VF1 plus M2 VF2. Then half M1 VI1 squared plus half M2 VI2 squared should be equal to what? Half M1 VF1 squared plus half M2 VF2 squared. So equation 1 and equation 2. Should we have something like that? Huh?
It is long.
I can look for one question quickly. I actually have one. I have 2. Huh? I have 2. There's one from KZN. It's Asizipe and Sizipo. They were playing on a cart. I just don't remember which year. Or we can just quickly scan. Okay, while you're busy, I can scan. All right. Now, what about inelastic? In an inelastic collision, guys, can I move? Can I move? From here, we only have what? We have 2 questions to do in this paper, vertical and Newton's laws. Okay, I'm not getting a response, but I'm moving. Inelastic collision, what do we know? Momentum is still conserved, please, don't be deceived. Momentum is what? Conserved, but kinetic energy is not conserved. Signs of inelastic collision. Physical science. Number 1, object changes shape. Object what? Changes shape. Number 2, object moves together as a unit. But then they'll ask you, why is kinetic energy not conserved? Here. Energy is converted to other forms. Give me other forms that you may have.
Sound, heat,
Other forms of energy. Such as, yes, you're right. Such as what? Sound, heat, light, vibration. Vibration is an energy. So when you have accidents, there's a lot of things that happen. So that all those energies are coming from the same kinetic energy. Remember the law of energy. Energy cannot be created nor destroyed, but transformed from one form to another. All right, so please take note of the elastic and the inelastic. Inelastic momentum is still conserved, but kinetic energy is not conserved. Any question here? Please let me know. Any question? Everybody good? Responses are of importance to me, so we can deal with any question that we may have. Okay, let's go and deal with vertical projectile. This is where things can go south. Why are you laughing? And it's a beautiful one. It's a graph question. It's a beautiful one. Graph question. I need to quickly go through. Once we're done, please remind me. I want to go through graph of electric circuits with us. Just remind me. There we go. 14 marks. And if anybody has any question, or once I'm done with question 2, I want 1 hour to take your own questions. If there is any questions that you still need help with, we can try for 1 hour or so on any topic. But after we are done with this. Okay, guys, how did you guys fare with this vertical projectile motion? The graph below represents the motion of a 500 gram. Problem number 1. What is our problem number 1? The mass is not 500. The mass is what? It's only in chemistry that we leave it as grams. Did you guys change? Huh? You didn't need it? Okay. You sure? Oh, okay, we'll see. Vertically downwards from a certain height above the ground and bounces on the ground a number of times. Ignore. Let's do something here. Let's call this A, B, C, D, E, F, G, and H. Can we sketch? If we can sketch, it will really help us. So, they said it was thrown from what? Was it dropped or what? Huh? Thrown vertically downwards, okay, from a height. So, this would be my A. Now, it's going to reach a maximum. It was dropped, right? It will reach the ground, and that will be what? B. Now, what do you notice? Do you notice that B and C are at the same time? Oh, by the way, let's do something. Let's do something before we go ahead. Do you notice this one is a positive, right? This is a negative, positive, positive. I want you to see something. So you would notice that they've chosen, it's moving down, right? They've chosen down as positive. So A and B is down. C and D is negative. So it should be going where? Up. D and E, that will inform our graph. F and G, negative is up. Okay, let's look at this now. So A and B, we said down. But it bounces back immediately, right? And reaches a maximum height D, all right, which is 0, and then goes down again. So what would that be? This would be what? C. So B and C happens at the same time. B, C, D, E and F, similar. Then what do we have? G is maximum height and H is on the ground. If you understand this, you have helped yourself in a lot of ways. Please talk to me. Is my graph making sense? If the examiner says draw a position time graph, that's your answer there. So just understanding how it bounces. First question, what is a projectile?
Object it is given an initial velocity and only as a possible.
Alright, so projectile is the object. An object that has been given what? An initial velocity, and the only force acting upon it is the force of what? Gravity. Please, I know you are good at late night stuff with definitions. Please, no one should get into tomorrow with a... Please go back to your prelims, the list. Somebody can find it and resend. That's what they're going to ask you again. That same list. If you can just scroll and find it, please resend it. Name the physical quantity represented by the gradient. If you don't know how to calculate, if you don't remember, just do a simple calculation. What is your gradient? Velocity. So gradient would be what? Change in, no, you're right, change in velocity over change in time, which is what? But don't just say acceleration here. Acceleration due to gravity. Why? It is a free fall. Number, yeah. All right. Number of times the object reaches maximum height. Twice. So we're looking at where velocity is what? 0. Magnitude of the velocity with which the ball strikes the ground during the second bounce. Where's the second bounce? Look at the second bounce. The second bounce, this is the first, right? Second bounce is E and F. So let's go to E. But we don't know that velocity. But it's exactly the same thing. You see this? C and D. and E. This is a perfect parabola. So the value here is the exact value. Wait, where are we looking at?
C.
We're looking at the what? Second bounce, right? Is it?
Yes. During the second bounce. Velocity of the second bounce.
Oh, we're looking at E and F, right? Oh, so here,
No, in C.
yeah, it's E and C, right? Yeah. Because our first bounce is at B, and our second bounce is at what? E. And that value is the exact same value as that. And what's your answer?
14.
The examiner says magnitude, so it's 14 meters per second. Calculate the height above the ground from which the object was thrown. What did you do?
Delta.
Yeah.
Okay, let's make a list. Let's make a list of what we have. Let's make a list quickly of what we have. I needed that graph. So what are we looking for? We're looking for point A. Okay, what can you tell me?
We've got the initial velocity.
Down as positive. We have the initial velocity at point A as what? 4. What else?
We have final velocity.
At B, right? Lovely. We have final velocity as what? 33, 4. What else? Time. 3 seconds. I think we're done. We don't even need acceleration. But we can use it. What's our G? It's a positive gradient. So I can use delta y equals to Vf plus Vi over 2. Do you remember? I don't know if you know that formula.
This is a. Maybe you explained it before.
Okay, let's check if it's going to be correct. What did you guys get? Okay, do you want to try for me?
This formula is not the actual formula. It is 56,1 meters.
Is it what you used?
No,
Just confirm for me. You used it. 56, comma?
It's not the real formula.
What do you mean it's not a real formula? It's
a
there.
combination, isn't it?
It's there on the formula page.
Yeah, but it's only the other three are actual formulas. This is just a combination.
Of what?
I don't know.
Do you know that your Vf squared, your delta y equals to Vi plus 8 is a combination? You tell me it's not a real formula? It's a combination. Okay. But guys, can we do this without equations of motion? I want us to try without equations of motion. What are we going to do? If you see 3.4, they said without equation, but I want us to apply it to 3.3. How do you find displacement when you are given velocity time graph? You find the area of the shape. I want us to try it quickly. So I'm working with A and what? B. Let's use a blue marker for that. Can we find that A to B, right? What shape is this? X-axis being the base. What shape would you call this? A trapezium. And a trapezium can be broken down into a rectangle and a triangle. So I could find my displacement, because should in case the examiner asks us to do that without equations of motion, then I'll say my delta y is the area of triangle plus the area of what? A rectangle, which is what? Half base times height plus, okay, come, let's do it together. What is our base? Our base is 3. What is the height? 33,4 minus 4. Please, even if it's on this side, you put the minus in. 33,4 minus 4, which is what? 29,4. Let's see what we're going to get. Plus that tiny rectangle there, 4 times 3. Please put this in a calculator and let's see what we have. Let's confirm the answer. You didn't put it.
I did.
Because I know you now. 56,1. All right, so please, the area under a velocity time graph, I'll need you to write that down. Area under a VT graph would give us what? Displacement. Very, very important. Without using the equations of motion, calculate the numerical value of t. Midpoint. It's just the midpoint of 3 and what? 5,8. But be careful. No, it's fine. Midpoint is fine. Okay, 3.4.1. Because I told you it's a perfect what? Parabola. So t will be what? 3 plus 5,86 divided by 2. What's your answer? 4,43.
Yeah.
So can you use that?
What?
Can you use that?
Can I use?
That 1.4 formula?
Yeah. You just know how to use it.
Isn't it?
Okay, what is
Oh,
this?
so like I'm confused.
They said without using the equations of motion. What did you use?
All 6 marks is going.
Use the equations of motion. Wow. 3.4.2. Okay. Maximum height reached by the ball after the second bounce. Can we go back to what are we looking for?
So I got the first one right, but for some reason I forgot it.
Second bounce. So we are looking for G. Do we agree?
G. Oh,
Maximum height reached by the ball after the first bounce, sorry. D. Do we agree?
okay.
This is the first bounce. We're looking for the height of D, which is basically what I did just now. So we are looking for, what are we looking for? We're looking for that. Maximum height reached. And you would notice it's between C and D. Maximum, that's why sketching just makes it a lot easier for us. It's between C and D. And you would notice the shape that you see between C and D. What shape is that? It's a triangle. So what do we need? Can we just find the area of that small triangle? So guys, please, analysis is very, very important. Area is half base times what? Height. What's the base? Between C and D. What was this? 4,43. So what is 4,43 minus 3? 1,43. And what is the height? Negative 14. What would that give us?
10 meters.
Stop line.
10,0.
10, comma?
0.
But they said height, right? So height is always positive. You used equations of motion. You got 10. But you'll be marked wrong. Like 0. 0. Any question? Yes?
Can I see the answer for 3.2.3?
3.3 you mean?
Oh, 3.2.3.
3.2.3. Magnitude of the velocity at which the ball reaches the ground during the second bounce. What's our answer?
Negative
14.
3.24.
All right. Are we good, guys? So using equations of motion and using... Okay, last question on my side. Then I'll quickly talk about graphs of electric circuits. And then I would receive, if there is any question from you, maybe for 30 minutes, we can look at whatever question you have. Otherwise, you will get a response from fellow learners or at 5 in the morning, 4, 5 in the morning. Quickly, let's answer this one.
No,
13 minutes?
It's upside down.
So it's right.
As long as you don't turn my board. Now, lady, where is this 57,12 coming from?
No, but explain to me the logistics.
Now, lady,
Impossible to do. You're pushing a box from here and the seat. There's no way it's even good to see. You can. No, you can't. Yes, you can.
lady.
So you must.
Now, lady, talk to me. Where is this? Did we get 57,12 anywhere?
Yeah. No, did you?
57,12.
No. We got 56,1.
Now, lady, please let me know so we are on the same page.
But how are you writing like this?
Okay. Can we mark quickly? Let's mark in 10 minutes together. All right. A force of magnitude 50 newtons is acting at an angle of 30 degrees on a 2 kg object to push the object against a horizontal ceiling, as shown in the diagram below. The object accelerates to the left at 20 meters per second. Ignore air resistance. The coefficient of kinetic friction between the object and the surface of the ceiling is unknown. All right, state Newton's second law of motion in words. I skip. 2.2. Draw a labeled free body diagram. Okay, please tell me the forces that you have, guys. Forces that we have. Talk to me. Forces.
Oh, we have normal. Oh, we have
Applied force.
Mm-hmm.
Okay. Fg is coming down, right?
Yeah.
What about normal?
coming down.
Okay, normal is also coming down. What else?
FK.
Friction.
How?
It's an object on the surface.
Yeah, but how? How is it acting?
Oh, to the right.
To the right, and it's horizontal. So we have what? Applied force. We have what? What did we say? Normal. Please, for your exam tomorrow, write it in full, please. Friction. What else? Force of gravity. Is this what we have? Okay. Number 3. Calculate the magnitude of the normal force. Now, what I like to do is before I start any other calculation, can we change that applied force? And if we change it, what do we mean by changing? Let's just do it a tiny little force here. I'll have my friction. I'll have my normal. I'll have my gravity. Now, then, can I then change this one to what? Fy and what? Fx. Question is, what is Fy and Fx? Please quickly go back to your diagram. Your diagram would always assist you. Check that and that. Now, you notice that Fy is the one opposite the angle. What would it be? 50 sine 30, and that should be 25 newtons. And Fx would be what? 50 cos what? 30, which will give you 25 root 3. Because that's root 3 over 2. All right. So it's important to do that quick analysis before you even start calculating. Now, the examiner says magnitude of the normal force. What do you think the magnitude of the normal force would be? If you look at your diagram, you would notice that there are 2 forces pointing down and 1 force pointing up. So the force pointing down, can we add them together? Fg plus normal equals to Fy. What is my normal therefore? Fy minus Fg. What is my Fy? What did we say? And this is Fy minus mg. What did we say Fy is again? 50 sine what? 30 minus, what's the mass? 2 times 9,8. What's your answer? 7,6 or something. No, I'm lying. Please give me an... yeah. Because it's 25 minus 19,6. Huh? What do you mean minus?
Minus 2 times.
What are you guys talking about?
Wouldn't it be plus? Because
How?
it's in the same direction.
What you guys smoking?
Because it's pushing the object onto the surface.
Okay, hold on. There are 2 forces acting down
Yeah.
and 1 acting... So they are equal. Come on. The forces acting down, how many forces are acting down? 2.
Yes.
And there's 1 acting up. Do we agree 1 is going up?
Yeah.
Which one is going up? Fy. Come on, where are we losing it?
But why are you saying up is equal to down? Doesn't it tell us it's the net equals to 0?
Huh?
Then it tells us up equals
Now, how is this object moving? This object is moving what? Horizontally. So the vertical forces are at equilibrium. Otherwise, the object will drop. So the object is moving horizontally. Vertically, the one going down is the same as the one going up. Hence, the object is not moving up nor down. So F net vertical is 0. Are we on the same page? Where am I losing you?
No, you're right.
So,
I see what you're saying.
FG plus normal. These ones are the ones acting down. This equal to the one acting where? Up. So if I move this down, I have that. So give me an answer. 7. Because that's 25 minus 19. Or 8. 7 comma something. 5? All right. So the free body, why did you not trust your free body diagram?
You never slept. So you don't have it.
So please, before you work, always deal with vertical and remember we mentioned it under work as well. Make sure it's vertical and horizontal. We good? Your face is still not so. Guys, are we okay? Talk to me. Let me leave these guys here. Those of you that are at home, are you okay with this explanation? So every time you have something inclined, just quickly change it before you calculate vertical and horizontal. Magnitude of the kinetic what? Friction. No, of the coefficient. How do we get coefficient, by the way? How do we get coefficient? Okay, let's see what we need. What do we need? We know that Fk equals to what? Mu Kn. Now, do we have our normal force? Yes. But the question is, do we have friction? We don't have. So can we then say F net is equal to what? Ma. Let's go back to our diagram. What are the horizontal forces? Do you see it's Fx and what? Friction. Object is moving in this direction, plus and minus. So can we sort that out to say it's going to be Fx plus negative what? Friction equals to what? Ma. What is Fx, by the way? We said 50 cos what? 30 minus friction. What is the mass? 2. And acceleration is what? 20. Please get me frictional force here quickly. Do the math. 50 cos 20 minus 40. No worry, you won't use your head. Yes, Shamil, come. Time. We move the Fk over, it becomes positive on that side. 2 times 20 is 40. We bring it over here.
Negative 3,30.
Negative.
Yeah. 25, so 3,30. Because I have to divide by the negative of that.
What did you do? Because I don't want. Okay, wait.
Minus.
Oh, you did 40 minus. And your answer is what?
3,3.
Round off yet?
3,301.
I need 4 decimal places.
3013.
Well, we're not running off. We're not done, right? Remember, we're looking for that. Mu K N. 3,3013. What did we get for a normal force? 5, something. Force 5,4. All right. Give me an answer. It must be 0, something.
0,61.
0, and remember, no units. Let's put it there. No units. Why no units? It is a ratio of forces. You complicated it.
No, just something's not clicking in my head.
What? Where are you? Talk to me. Talk to me. Guys, please ask your questions. Is there any question you would like to ask here? Ask. Ask away, ask away, ask away. So your free body diagram will always give you your answer. If the two forces are in the same direction, we add. Okay. The force is now acting at a smaller angle. What effect will this have on the following? Will it have an effect on the coefficient of kinetic friction? No. The coefficient talks about the degree of roughness of the surface. Not on friction. It will have an impact on friction, not on the coefficient of friction.
Basically, any changes in the surface.
You understand? When we say coefficient, coefficient is how rough the surface is. That one will not change. Whether you bend the force, the surface remains the surface. But it will affect friction. So the answer for this one is that it remains what? The same. Please take note. It does not affect, nothing affects coefficient of, the only thing that can affect it would be what? If you put grease to reduce friction. All right, how will this affect the kinetic frictional force acting? Let's reason here. If we use a smaller angle, what will happen to the kinetic friction? Okay, if you don't understand, let's trace it back. All right? How will this affect the kinetic friction? You know what? Before we go ahead and do any funny answer, before you put it, we have to first calculate normal. It will affect normal. Absolutely. No. Because our friction is connected to normal. So whatever happens to normal will happen to what? Friction.
So can you take that 50 sine 30 minus whatever, just decrease the angle?
Yes, that's what I'm saying. So you decrease that angle there to 10.
Yeah.
So decrease that angle and check that value. You get a smaller answer. And you can also use your knowledge of tricks. But I would say put a value there, because your normal will affect your friction. So if you decrease that value should what? Normal should decrease. Okay. So how would I then respond? I would say a smaller angle decreases what? Normal. Normal force. And here is it. Normal is directly proportional to friction. Because of what's your formula saying? Fk equals to what? Mu k n. Do you notice that's a constant? So if your normal goes up, friction would go up. In this case, normal has decreased because of that angle. Therefore, kinetic friction will also what? Decrease.
So, we have a horizontal plane and an object on the horizontal plane, and there's a F applied, but it's at an angle. They ask you to calculate the normal. Then you can also say up is equal to down. Like how we done now.
Yes, if the object is moving horizontally,
Yes.
the vertical forces will be the same. Because check, Newton's second law states that what? The object will accelerate in the direction of the net force. Now, there are two net forces acting. Vertical net force, horizontal net force. So if the object is not going up or down, it means that the net force vertical is 0. If the object is moving horizontally, then the net force horizontally now causes the object to do what? To accelerate. Guys, are we okay with this? All of this? Please talk to me. Everybody okay? Okay. All right, guys. We are done with the full paper. I sent you a paper to work with, but quickly. I said I want to do one quick summary, 5 minutes, please, on graphs, especially graph of electricity. Please, just 1 or 2 things that I wanted to know there. If the examiner gives you this, V and I, and they give you that, because I wanted to watch what we're going to do here quickly. I know that EMF is what? I into what? R plus R. EMF is V external plus IR. Okay, but V external is on my y-axis. You know all of these tricks. There's just something I want to remind you of. If I bring this here, what do I have? E minus IR will be equal to what? V. But this is my y, and that is my what? X. What do we do here? If we rearrange negative Ri plus E, y equals to what? Mx plus what? C. You know this, we've done this over and over again, and this applies to every topic. So the idea is to make sure that I have my y as V and I have my I as X. Therefore, M will be equal to what? Negative R, and my y-intercept becomes my EMF. But that's not really what I want us to check now. This point is called a short circuit current, which is known as the total current in the circuit. What do I want us to see? Let's put an example here. 6. Let's have 0 there, and let's have 3 here. Now, I have 2 here, I have 1 here. My OCD will not allow me to do that stuff. So check this. The examiner is giving us such thing there. Lies. Now look at this. The examiner says, what is the EMF? 6 volts. What is the total current in this circuit? 3 amps. When the current is 2 amps, what is the lost volt? Remember, when the cell is opened, when the switch is opened, we measure EMF, right? When we close the switch, what happens? There is a drop. The EMF becomes the V external, by we lose a particular value. So look at this. What is the lost volt when the voltage, when the current is 2? So 5, you're correct. This is what we're really saying. EMF is this. But when the current is 2, our V external is now 1. The difference here is your V lost. So what's the difference? We have lost what? 5 volts. That is very, very important. And obviously your gradient is your R. I want to do one more. I want to flip these things over. Please always work it out. Always work it out. Work it out.
Secondly, in that formula, I,
Yeah.
is that I total?
Huh?
Is that I total in the EMF formula?
Yes. I total. Are we okay with that concept? All right. Write quickly. Okay, Guys, what if I flip the y? Please always take note of what you have on the y and what you have on the x before you jump into answering the questions. Please. Very, very important. What if I have I here and I have V there? Will this still be my EMF? Let's work with the equation quickly. So E will be what? IR plus what? Now, do you notice that I is my what? Y-axis. So let's factor out I there. So what do we have? I into what? R plus R. So what is I? E over what? Okay, but I have V there, so we need to get V. Sorry. We need to get V first. So E will be what? V plus IR. Let's move that there. What do we have? E minus V equals to what? IR. Can I divide both by R now? What do I have? I equals to what? E over R minus V over R. But I want my X to be V. So I'm going to rearrange and say minus V over R plus what? Now look at what I'm going to write. Minus 1 over R V plus, look at the difference. Y equals to what? MX plus what? Do you notice that this is exactly where I want it? So what is my gradient? Negative 1 over R. Because it makes sense. I over V is my resistance. But what is my C? So it's very different from the first graph. How do I get my EMF now? My EMF I'll get from the Y what? Intercept, which is equal to what? E over what? R. Please, that is very, very important. I'd like you to take note of this graph as well. If you can take a picture, send it on the group, and so that everyone can walk through. All right, guys. I hope we are good. Please watch the lessons again, but most importantly, answer a full paper. If you have 2 full papers, why not? If anybody has a question, send it on the group. If a question is sent on the group, please assist. Please assist, and let's work together as a team. All right, at this point, can I wish you good luck with physics? But if there's any question, please do share, and let's work together. I will not be available on my phone, as I told you, until early hours of the morning. But that doesn't mean we shouldn't ask. Please ask. And guys, like I'm saying, ask. And let's go forth and back. I think the answer is, I think the answer is. Then I can, respond if I see all the arguments. But at any time I have time, I'll do. All right. Have a lovely evening, everybody. The lesson is available for rewatch immediately. Goodbye.
My sensing is upside down. It's not working, but